There's your assignment, e-learning day. We're going to take some notes. So what do we do with chemical reactions when we can see that they obviously do not balance out? By looking at our iron, we can see that they are not balanced out. And if we look at our sulfate, we can also see that they're not balanced out. So what do? We need to balance them. How do we balance them? Well, we use coefficients, and coefficients, if you remember, go in front of the compound. They do not go in the middle. If you put them in the middle, you're changing some things up, and that's not what we do. We never do that. We always would put them in the coefficients in the front of the compound and or element when we see it in the reaction. What does this look like? Well, let's look at this reaction a little bit closer. When we see here, we can, again, same reaction, but we're going to actually balance this one. Over a while, I've learned a couple things that help students. When I was learning it, it was just kind of like, put numbers where you need to put them. I have found that works, but it doesn't always work for everybody. This tends to work a little bit better. We make our tombstone. The I is really long, and P. Actually, it's reactants and products, but some people have it there. So we have our accounting chart set up. I'm going to account for everything that's present. So I have my iron, I have my copper, and I like to go just in order in which we see them. Now the sulfate, you can do a couple different ways. You can write out the sulfur separate and the oxygen separate. Not a big fan of that. I don't like doing it that way. I've seen some people put in an X and then substitute X in for both sides. And again, don't like doing that. I've actually found students getting really confused by that. One thing that we can do, because if we look very closely, sulfate is together on both sides, as we can see with a little bit of the highlighting. And so because it's together on both sides, I can go in and actually just write SO4, and I'm going to put it in parentheses because it's together. It's together on both sides. Therefore, it makes my life a little bit easier, and that's what we do in chemistry. We're making your life easier. So, I do my accounting. I have 1 iron on the reactant side and 2 on the product. I have 1 copper on the reactant side and 1 on my product. I have 1 sulfate on the reactant side and 3 sulfate on the product side. Now, where did that 3 come from? Well, that came from the reverse crisscross of the iron. We're going to look at one of those when we actually come back to school and go into this further. We can see now that we have some things that aren't balanced. Now, a lot of times students go, where do I start? You have to start somewhere. So you might as well start with, say, the sulfate. It's a polyatomic ion. It's somewhere and everywhere. And so we start. And so I put a 3 in front of my copper 2 sulfate, which now changes the 3 there and a 3 there. I can now see that my copper on my product side is going to need a 3. And I'm also going to need a 2 in front of my iron on my reactant side. 2 now, if I look, everything is balanced and green is good. We'll look at some more as we continue further on. 2 more reactions that we can look at. Still going to make my little tombstone here, my reactants, products, and now I start making an account of what I have. I have a sodium, I have a hydrogen carbonate. Now, sometimes we have to look at that and say, oh, I have a carbonate. However, where did that carbon dioxide come from? That carbon had to have come from the carbonate on the sodium hydrogen carbonate, meaning I can't split it up like I did on the previous example. So what I have to do now is write everything out. Ooh, should probably change the colors so that's a little easier to write. And so we can see that I have to break it up. Now, why it breaks up that way and how it does that, we'll look at that a little bit further in this unit. Looking on both sides, I have a sodium on the reactant side and 2 on the product. I have a hydrogen on the reactant side and 2 on the product. I have a carbon on the reactant side, but I have 2 on the product, and I have to be careful and look, and I have 1, 2 to give me those 2. When I see my oxygen, things get a little bit dicey in that I have 3 on the reactant side, but now I got to count a little bit. I go 3 plus 1 gives me 4, plus 2 gives me 6. Now when I look at this, I can see that all of them are multiples of 2, which means all I have to do is put a 2 in front of my sodium hydrogen carbonate or my sodium bicarbonate, depending on what you want to call it, and everything balances out. Well, that's nice for that one. Now we'll look at the next one. The next one, we have iron 3 chloride solution, that's why it's AQ, reacting with a silver sulfate to produce a solid sodium chloride. I'm sorry, not a sodium chloride, a silver chloride, and a iron 3 sulfate. So same thing as before, I do come through and I start my accounting. Iron, chlorine, silver, and sulfate. Because it's together on both sides, I can make my life easier again. I have 1 iron on the reactant side and 2 on the product. I have 3 chlorine on the reactant side and 1 on the product. I have 2 silver on the reactant side and 1 on the product. I have 2, no I don't have 2, and again, be careful, that 4 goes for the SO4, and so I actually only have 1 sulfate on the reactant side and 3 on the product. Now again, where do I start? It doesn't matter where you start, but you have to start somewhere. Some people will start with the sulfate again. Why not? Worked for us last time. So I'll put a 3 in front of the silver 1 sulfate, but that makes that a 6. Well, that means to balance the silvers out, I'm going to need to put a 6 in front of my silver 1 chloride. And then this means number of chlorine is now jumped up to 6. And now I can see that all I need is a 2 in front of my iron 3 chloride to balance everything out for this reaction. And it's okay that I didn't put numbers in front of everything. It doesn't always have to happen that way, but as long as we're balanced, that's all that matters, because the law of conservation of mass holds true. This next reaction here, we have a neutralization reaction of hydrochloric acid reacting with sodium hydroxide to make a sodium chloride solution and water. Again, make my accounting IP, and I have a hydrogen, I have a chlorine, I have a sodium, and hydroxide. How do I know I can put the hydroxide? Well, water can technically be written as HOH, and we'll see that more often, so I can kind of have it written out that way. Now when I look at it, I can see that I have 2 or 1 hydrogen and 1 on the other. That doesn't look right. And do 1. I have chlorine and I have sodium. What is this nonsense? It's balanced as it's written. And that's okay. That can happen. And usually most people, it's either, sometimes you might always want to check your reaction out right, but sometimes it is right. And we go on to the next one. We have a silver. Just going to keep the color the same this time. My nitrates are together, so I'm going to keep it together. I have iron, and I have chlorine. I have 1 silver on the reactant side, 1 silver on the product side. 1 nitrate on the reactant side, 3 nitrate on the product side. My iron, I have 1 and 1, but my chlorine have 3 and 1. So can't really start with some things, but let's start where we can. Now I'm going to go with the nitrate. I'm going to put a 3 in front of my silver 1 nitrate. This then changes my silver to on the reactant side to 3. Need to put a 3 then in front of my silver 1 chloride to balance out everything. So what I have found is that using the chart on the side that I have here works great. It makes life a lot easier for, I think, everyone in keeping everything together. Hopefully you watched this, took some notes, tried some out, and we'll continue these notes when we come back from this.